All right, section 5-1, this is writing fractions as decimals. All right, so the first thing we want to talk about in this section is the terminating decimal and repeating decimal. You'll see these two terms on page 228 and 229. And we're just going to give some examples of some different things. You're not going to see these examples in your book, but you do see where it says terminating decimal and repeating decimal. And so a terminating decimal is a decimal, or just a number in general, that stops. It terminates. So a number like 0.3, there's nothing else after that, right? So it terminated. 103.41, it stopped at the 1. There's nothing else after it. The -4 stopped, right? Where's the decimal in -4? It's at the end of the number. And then you have -6.2. Also, it just stops at the 2. But even though it terminates and it stops on your end, I do want you to understand, though, that there are zeros after these numbers that go on forever. So 0.3 is really 0.30, and 103.41 is 103.410, just like the 0.3 is 0.30000 forever. -4, -4.000, and then the same with -6.2, 000 forever and ever. All right, and then we have repeating decimals here. And repeating decimals, this is just where a number continues forever, but it also has a repeating pattern. So in this case, the 0.2 that has the bar over top of it, that means that the 2's go on forever, right? Forever and ever and ever. It's not zeros forever, it's 2's. The 0.78 with the repeating bar over both, it goes 0.78787878 forever and ever and ever. There are no zeros for that. And then you have the last one, -6.54, and the repeating bar is only over the 4. So as you can see in here, it goes -6.5, and then it's 4's forever because the bar is only over the 4. All right, so those are two important vocabulary as we move forward. All right, so we're going to start with example number 1. It says to write 3/8 as a decimal. And so we have 3/8, and there's a couple other things here that I want to make sure we're aware of. And the first one is that we have top divided by bottom, right? Anytime we have top divided by bottom, that is what we're doing when we do a calculator. So we put in the top number, and then we divide by the bottom number, right? So that's up here. But on the bottom, when we're trying to do it on paper, this is what you're doing. You are dividing the bottom number into the top number. All right, so that's what we're going to start with here. 3 divided by 8 if we're doing a calculator. If we're not and we're doing it on paper, then it's the bottom number 8 dividing into 3. All right, so I know 8 does not go into 3, so I put a 0, and then it goes into 30 3 times. I get 24. Subtract is 6. I'm going to drop a 0, wrong 0 there. 8 goes into 60 7 times, which gives me 56, and then I subtract, I get 4, and 8 goes into 40 now, 5 times exactly, so you end up with nothing left. But the part is that I want you to see is we're taking the bottom number and dividing it into the top. That's what's written down here. And then make sure you put your decimals in there. That's another key point. So 3/8 is the same as the decimal 0.375, which makes it a terminating decimal since it stops at the 5, and then after the 5 it's 0,000 forever and ever and ever. We just don't have to write them. All right, example 2 on page 229, we have 4 3/4. Now again for this, we can do this a couple different ways. But basically, we're going to have 4 point something. Anytime you have a mixed number, the big number out in front, the 4, becomes your 4 point. All right. So what we're going to do is we're going to find whatever this fraction is, and then that is going to be going right there beside us where the decimal is. All right. So for 3/4 again, we're going to do bottom into top. This should be an easy one. You might already know this one, which is great. 4 does not go into 3, or it goes 0 times. Make sure you get the decimals in there. 4 goes into 37 times. You get 28. Subtract is 2. Drop a 0. 4 goes into 20 5 times exactly. So there's nothing left. 0.75 is the decimal. But what happens is that 0 basically just goes there, and then the 0.75 goes there. So you kind of take off the decimal, anything in front, and then what's after it is the 75. So 4.75. That was in example 2B, if you see that there. All right, example 3 at the bottom of page 229, we have negative 6 over 11. It wants us to write this as a decimal and use a repeating bar if it repeats. So again, we're going to do top divided by bottom. If we had a calculator, it'd just be negative 6 divided by 11. You'd type that in exactly and it would give you the answer. But when we're doing it on paper, we've got to do bottom into top. Now, what you want to notice here is I'm not writing the negative in there, all right? We already know how to divide negatives and positives. In negative 6 divided by 11, every 2 negatives cancel out. Well, there's only one negative sign, so that means that no negatives will cancel out, and my answer becomes negative whatever I get down here in this division. So I'm going to do bottom into top. Just 11 into 6 doesn't go into 6. 0 times. It goes into 65 times. 11 times 5 is 55. Subtract is 5. Drop a 0. Now 11 goes into 50. We've got 4 times. So 11 times 4 is 44. Subtract 50 minus 44, you get 6. And then we drop again. Now what you might want to notice here is up here I was dividing into 60, and then here I was dividing into 50, and then here I'm going to divide back into 60. And what happens is 11 goes into 65 times, and you might notice that this starts to have a pattern. Again, we subtract, I get 5, drop a 0, so I'm again going to divide into 50 the same way I divided into 50 there. So we're going to have 4 again, and then it's going to be 5 again, and then 4 again, and that pattern will continue. So the answer I'm going to write down is negative 0.54, and I'm going to put a repeating bar over both numbers since it repeats over and over and over. All right, and that's the only thing. You put your repeating bar over just numbers that repeat. If you notice in part B, 2/15, once you divide that, you get 0.1, and the 3 is the only number that repeats, so the 3 goes on forever. That's the only number that you put the bar around. So that was for part B. All right, example 4, next page, 230. Says, during the 2005 Masters Tournament, Tiger Woods' first shot landed on the fairway 32 of 56 times. Notice I've wrote a fraction there. He hit the fairway, which is the short grass when you golf. He was able to hit it straight down the middle, basically 32 times out of 56 different holes. And to the nearest thousandth, what part of the time did his shot land on the fairway? So what I'm going to allow you to do on this particular one is use a calculator. All right. How do I put this in a calculator? Same as the other ones, top divided by bottom. You type it in exactly how you see it. It's only when you do it by paper that you write the bottom number first and you divide it into the top number. And so that's what we're going to do. And what we get here, once we divide it in the calculator, you can see this already. You end up with 0.57148. Now, the cool part about this, if you were seeing this, this number actually repeats. All 6 of those digits go on forever and ever. So the next digit would be a 5, and then a 7, and then a 1. It goes continually after that. But what this wants you to do is round to the nearest thousandth. So I'm going to show you a little trick. I don't know if this will help you, but if you write out the word 1,000 or number 1,000, there are 3 zeros. Well, which number am I going to round? the third decimal place. So if there's 3 zeros here, 3 numbers, 3 zeros in the number 1,000, you round to the third decimal place. So if I were rounding this, my answer to the nearest thousandth would be 57, and then the 1 either goes up or stays the same. I base that on the 4. The 4 is a weak number, so 1 remains the same. And so that becomes my decimal, rounded to the nearest thousandth. If we were doing this in percent form, we'd move the decimal 2 places to the right. We'd have 57.1%. And you can also see in there where they simplified this, and they got 4/7 is the fraction simplified. So all of those are equal answers, but this wanted it in decimal form. All right, example 5, we're putting a less than or greater than or equal to sign in there. We're just checking each one. Now, the title of this section is writing fractions as decimals. So the way that we're going to solve it today is by writing these fractions as decimals. So if I don't have it in decimal form, that's what I'm going to do. 3/5, I'm going to change it. 5 doesn't go into 3, or it goes 0 times. We add a 0 to 3 and make 30. 5 goes into 30 6 times with nothing left. So my decimal here ends up being 0.6, and we're comparing that to 0.75. Now, just to be careful here, I know this is a mistake that some people make. We're not comparing 6 to 75. Obviously, 75 is bigger than 6. They're both positives. But what we want to do here is, if this has 2 digits past the decimal, we want this to have 2 digits. So what's the next digit in 0.6? It is 0. So in 0.6, it's the same as 0.60. Now as you compare them, obviously 75 is bigger. So I give 2 dots for the bigger side, and this side is smaller, so 1 dot, and then I connect. I get a less than sign. All right, so part B here, number 5, this has -5/8 and -6/9. We're just going over this because of the negatives. I want to make sure we don't get confused here. But again, we're just taking these decimals, or these fractions, to decimals, all right? So bottom into top, take 8 and divide it into 5. Now, I'm not going to show the whole thing, but what I do want you to know is if we divided this all the way out, we would get 0.625, and it doesn't go anywhere further. So it would be zeros after that. Now, the other one, 9 dividing into 6. Notice I'm not writing the negatives down here when I divide. I'm going to keep those in my answers here. So this ends up being negative 0.625. And then down here, as I divide this one, I end up with this number repeating over and over. So what it ends up being, 9 goes into 6, 0.66, and it goes on forever. So what I would write down is just 0.6 with a repeating bar. This one over here is terminating. This one here is repeating. So which one's bigger? Well, as we just look at these right now, remember there's negatives. So the bigger negative is actually smaller, and the smaller negative number is actually a bigger number. So what we're comparing here, we're not comparing 6 and 625. Remember, just like the last one, we want to write out, if this has 3 digits, we want this to have 3 digits, as many as possible. So as you look at these numbers now, it becomes a lot different. 666 versus 625. Now again, you would be adding a 0 here and a 6 there if you needed to go further. But basically what happens is the bigger negative, which is 666, is actually smaller, and the smaller negative number on this side is actually bigger. So I get two dots for the bigger side, 1 dot for the smaller. It ends up with a greater than sign. All right, last example, page 231 says, in a survey of students, 13/20 of the boys and 17/25 of the girls make their own breakfast. Of those surveyed, do a greater fraction of boys or girls make their own breakfast? Now, I'm not going to show all this work. You guys do need to on your homework. But this decimal, if we were dividing bottom into top, that's what we would do. This decimal ends up being 0.65. And the other decimal over here, bottom into top, once again, make sure you divide. You guys need to show that work. But this decimal ends up being 0.68. So we're comparing the 6.5 to the 6.8. Notice it'd actually be the same as saying 65% and 68%. And obviously the greater fraction would be the 68%. So that would be the girls have the greater fraction. Best of luck. Thanks, guys.